All right, so today we're going to look at solving systems of equations another way. So in the previous video, we did solving linear systems of equations by graphing and substitution. Now this is another way or another method of doing it, and it's called elimination. So the way this works is you line up your equations. So basically that just means like have x and y lined up on top of each other. And you're going to multiply one of the equations so that your coefficients allow you to cancel something out. Meaning, say for instance, well, we'll do an example, or we'll do examples. So you want it to cancel out one of your equations, then you add or subtract the rest of the equation and solve for the remaining variable. Then you're going to substitute that variable that you found into one of the original equations, and that will allow you to solve for both. So I'll show you what that looks like because those steps are a little confusing when you just hear them. So we've got two equations on number one. We've got two equations. We've got x plus 7y equal to 17. And then we have on the bottom x minus y equal to negative 7. So the process of this is you want to look at these x's and these y's. You want to find a way that you can multiply something, or sometimes you may have to multiply it by both equations. You want to be able to cancel these out. So, for instance, if we look at x in the top and the bottom equation, if we want to cancel this out or make it 0, we need to make one of these negative x. So like say, for instance, we want to make the bottom negative x. We're going to multiply each of those terms by negative 1. So that would give us, I'm just going to rewrite the first term, or the first equation so that you can see it. The bottom, once I multiply that, that would come out to negative x plus y equal to positive 7. So you're going to set that up like it would be added together. Okay, so that means that now we can cross these two out because x minus x is just 0. So we got rid of it. Now you go and add the rest of what you have. So you're going to add these two together. So 7y plus y is 8y. And then you're going to add these two together. So 17 plus 7 is 24. So y equals 3, I think. Yeah. So we just solved for y by doing that. Now we're going to take that y that we just found, and we can plug it into either, let me get rid of this. We're going to plug it into either this equation or this equation. It doesn't matter. But you need to make sure you don't plug it into to the equation after you multiplied by it. You want to plug it into the original. So I'm going to plug it into this one. So I've got x minus 3 because we found that y equals 3, so we're going to plug in 3 for y, equal to negative 7. Then I'm going to add 3 to both sides. So that will give me x equal to negative 4. So my final answer, though I found x and y, my final answer is written negative 4, 3. So that's how you would solve those two systems of equations. Now, if you see in number 2, it's already set up for you. So in number 2, these two would mark out. So plus 2 a positive 2 minus a 2y would just be 0. So you would take these, add these together. So add your x's together. So that'll give you 8x equal to, add your integers together on the end, whatever it's equal to. That'd be 64. So then you're going to divide both sides by 8 because this is just solving equations. So x is equal to 8. Now you're going to take that 8 and plug it into the original equation, one of the original equations, and I'll just plug it into the top one. So that would be 3 times 8 because we said that x was 8, so we're just plugging that in, plus 2y equal to 22. 3 times 8 is 24, plus 2y equal 22. We're going to subtract both sides by 24. And that will give me 2y equal to negative 2. So then we're going to divide both sides by 2 to get y by itself. So y equals negative 1. So my final answer, because we just found what x and y is, my final answer would be written 8, negative 1. I'm going to show you a little bit harder of an example because those two are pretty straightforward and pretty easy. But I wanted you to see those so you could get the gist of what's going on. So let's look at number 5. Number 5 is a little bit different because if you notice, when I look at these two equations, there's not really anything. I can't just divide it or multiply it by negative 1 to get something to cross out. So what I suggest you do is just look at your x's. When you have a situation like this, look at your x's. And you need to find a common number for those two, almost like a common factor, that you could multiply something to each of these by and give you a common number. So if you look, the only difference between 5 and 2 is, or the next number that you could get to is 10. That's the only number that you could really do, that you could really get, like a greatest, or I guess a least common multiple is what you're looking for. So the least common multiple they have in common would be 10. Because if you take 5 times 1, that's just 5. And take 2 times 1, that's just 2. But then if you take 5 times 2, that would be 10. So we're going to start off with doing that. Because that will get us closer to where we need to be. So let's multiply the top row by 2. So that's going to give us 10x plus 6y equal to negative 14. So if we do that to the top, if we want to get this bottom to cancel out our x's, we need to multiply the bottom by negative 5. Because what that will give us is negative 5. We'll just distribute this. So negative 5 times a 2x is negative 10x. So now you can see that these will end up canceling out. And that's ultimately what the goal is. Okay? So your goal is to find two numbers or your least common multiple, and that will tell you what to multiply each of these by. So now we've got negative 5 times 7y, so that's going to be negative 35 equal to negative 15. So now we have those lined up, and we're able to now cross out one of our variables. So we're going to cross out this negative 10x, because 10x minus 10x is 0. And then we're left with what's here and here. So we're going to add those together. So we got 6y minus 35y. That's going to be negative 29y equal to negative 14 minus 15 is negative 29. So we're just going to divide each side by 29, by negative 29. And that will give us y is equal to 1, because negative 29 over negative 29 is a positive 1. Now we're going to take that and plug it into one of our original equations. So make sure that you go back and plug it into one of the original equations, not the second part here. Don't plug it in here because we've already multiplied it by something. We changed our equations. We want to multiply it by, or plug that y into one of the originals. So I'm going to do it by the first one. So 5x plus 3y. Now we said y is 1, so we're going to plug in 1 for y equal to negative 7. It's going to give me 5x plus 3 minus 7. We'll subtract 3 by both sides. It's going to give me 5x equal to negative 10. Now to get y by itself, we need to divide both sides by 5. So then that's going to give me x equal to negative 5, or negative 10 divided by 5, which is negative 2. So I just found x is negative 2, y is 1. So our final answer will be negative 2y. So I know it's a little confusing to think about, but when you have an equation like this where there's not a clear way to cancel out one of your variables, you're going to need to think about what's the least common multiple. What's the least number I can get in common between, I would just look at the x's. So I would pay attention to the x's. There may be an easier way with the y's, but basically you want to take two of those numbers and say, what's the least number I can get? And because that will make this as easy as possible for you. So that's the real struggle. And we'll do some examples of these. But those are the hard ones that you have to find two numbers to end up multiplying each of these equations by. So, but I'm telling you, the best way to think about it is, what's the least common multiple? What's the least number that these two have in common in terms of multiplying? So that is the elimination method for solving systems of equations.